Okay, and next we have deleting. Deleting is instead of append, you do a dot drop, or else you do a del, D-E-L. So deleting a column is very simple. Just DEL, the usual convention. And because the B column exists, you can always say df4 underscore 2 dot B. That will work as well. So that deletes away the column that's labeled B directly, right? You can also use the dot drop function. And the dot drop function can drop the column using columns attribute, the parameter. So if you have multiple columns, you put them in the list. B, comma, D, comma, G, something like that. If you delete a single row, then you refer to the row by the dot index name, the label, and you just say dot drop index equals to label. No, so this ambiguates in the sort of rare situation where index has a 0 label and column also has a 0 label. So which one do you want to delete? So it's safer because remember you are deleting data, something dangerous, right? So if you're doing that, you want to be absolutely sure you're referring the 0 to the row label or the column label. So always use columns equal or index equal, one of them. Okay, so here there are a few examples that we can always experiment with in our lab. So if you're ready, let's hop on to our lab. Okay, good. Mm-hmm. Just trying to get my slide up. Okay, so now we're ready to append first, and then we delete. Okay, so we'll do that. Let's just copy from the slide. We're going to append a new row. Can you see the row here? Okay, we're going to append a new row with ignore index being true. Okay, and then we print out what it is. So yeah, we have 8322 because df4 was originally 8322. Remember, we replaced the 9 to 2. And now we appended a new row. And we can always append two rows, two more new rows. Okay, so we can do that. So it's a list of lists like this to make it clear that we have two lists here. And then we have the columns being labeled the same way. And of course, if you don't remember what are the columns, you don't have to sort of type out df4 dot columns. What are you? Oh, A, B, C, D, and then you eyeball it and then you type it in. You can always sort of say, well, I want whatever df4 has. So that will work too. I think we are ready. We can just run it and see. Okay, so not just that we have added, well, we're using df4 and it is not df4 underscore 1, which has the 1, 2, 3, 4 added. So df4 is back to A3222107. And now we have added two more new rows, which are exactly what we have. Let's try to see what are the problems or effects if we don't have ignore index or we set it to false. Then what would be the problem? The problem will be that the new data frame that is being created will have by default the labels, the index labels 0 and 1. So if you append them, like I said, indexes in data frames can have any value, even when they are duplicating themselves across the index. It's okay, allowed, because ultimately you can use positional references to disambiguate them. However, is this the outcome you want? Do you want to, after append, and then do a reset of the index? It's a bit of a chore, right? And it sort of adds one more, two more lines that are not informative. not trying to save lines here, but then you're having to do that. It's like sweeping, cleaning the floor after you have baked a cake or what, and the floor is a bit flour dusted with flour and all that. You have to clean it, and that part of the operation is actually not in your recipe, right? So might as well just say that you have the intention to ignore it. Do whatever is right, pandas. Okay, so when you do that, then it will do the right thing and not produce 0101, but reset it. Okay, so that's the impact. So basically for me, I always have it set to true. Okay. Now, next, let's look at how we can drop columns using the newly added rows. So df4_2. We're going to drop columns A and C. So to do that, we need a list or else a tuple. All right, but because there are too many round parentheses there, probably better to just use a list of A and C listed like that. Okay, then what is going to happen? Well, we have 4 rows, but A and C are now gone. That's for df4_x. But the original is okay. Yeah. So now what if we say df4_2 dot drop columns, okay, A and C, and in place equals to true. Okay, now it's not returning anything. When you say in place is true, it will return none, nothing. And what happens to df4_2? Itself is being modified. Okay, so that is exactly what we expected. Now let's try to now delete from the original df4_2, because we're going to recompute everything. The original df4_2, we now drop first row and the last row. Okay, and we print out df4_y. So this is df4_2. We're going to drop the first row, the last row. So 2107, 5678 is what we have. Okay, and what if we want to drop both columns and rows? Can do that too. So we're going to say df4.2, the original one. Okay, drop indices 1 and 3, columns A and B. Can we do that? Let's see. Okay, so this is df4.4_2. So we're going to drop 1 and 3, so 8322, 5678. But columns A and B, so only 22 and 78. So you see that we can actually slice and dice and extract portions and this and that, every imaginable way to cut things up. You can definitely do it. So when we say cut things up, it is basically either you extract a few rows from the original data frame and you assemble a new subset, or you can make a full copy of the original database, the data frame, and delete off a few columns and rows to extract a huge subset. Either way, you will need drop. So drop, although it's deleting, is not necessarily sort of a cut operation. It can also be an extract or a subsetting operation, depending on how you use it, with the combination of other pandas functions. Okay, so with that, I think we have just gone through our experiment on the 4 important actions that we can do on data frames. And let's get ready for the next topic in data analytics using Python pandas.